Okay guys, openness part 2. So in the previous video we went back and we essentially took our geometry from 3D and chucked it on the ground plane, and then took like a, well I guess like a, what do you call it, a silhouette curve of it by just like grabbing that big face, there it is, and just chuck it into a curve, and then converted it to polyline, because openness likes polylines. Cool, so there's openness. What it needs is the sheet that we want to nest on. Like generally, you'll have one size sheet and go from there. But apparently you can have multiple sizes if you need to. But so we'll put that up there for now. We'll hook the geometry in last, which will kind of kick it off. Spacing between parts, that refers to, I want to, a number between, I don't know, probably about 5 and 30, but I'm going to set it at about 15. Maybe we'll go a bit less. Placement refers to like if it tries to optimize towards, like put everything against like a boundary, like the X axis or the Y axis. And I think an integer between 0 to like 6 is usually good, or it's actually 5 actually. There's like 6 options. I generally leave it on 0, but like play around with that depending on what you need. Tolerance refers like a nesting tolerance, like how far everything can move. I like to give it something kind of big, like 0.5. Doesn't sound a lot, but it is. Rotations refers to how much each part can rotate. I don't exactly know what it's a measurement of entirely, but I usually use it around 3, but it could refer to like radians or something. I don't know. See if you can find out. Iterations. So this is how many times the sort of routine will run. So it'll like do one bunch of nesting and it'll go, oh, can we do this more efficiently? If we still have iterations left, we'll do it, and we'll kind of like things will gradually get like closer and closer together essentially. So I'm going to run this at about, I don't know, 25 for now, and yeah, the more iterations, the longer it's going to take. Of course, seed is like a random number. I'll just leave it at 1 for now. That like sort of kicks things off. It seems to like toggles in like reset. Like sometimes in Kangaroo, you can just chuck a button in and it's all good, but I guess not here. Not false. Leave that to run. So what happened with openness? It can get a little bit annoying if you try and reset things and you've got a lot of geometry going on. It doesn't essentially like being used a whole lot, like if you've got a bunch of stuff. So just bear that in mind if you can, if you need your computer to run efficiently. So I'm going to plug this in. It's probably going to take anywhere from 2 to 4 minutes. So I'll pause the video and come back afterwards. But yeah, essentially there's all our shapes. There's one thing. I'm just going to flatten that geometry. So you do want to flatten that. Otherwise, you're not really going to nest well at all. So I'm going to hook that in. It's set to run, and we'll see how it goes. Okay, guys. Let's have a look at what openness has given us. And here are all our, how many parts? We have 104 parts, all nested. Like it's not the best. Like there could be a few more iterations done to minimize these, but like you get the point. Like it's a pretty powerful piece of software, considering that it's completely free. Like you'll pay usually thousands of dollars for access to this kind of software. So what we're going to do now is remember that these are all, these are all just curves, and we actually need to replace them with like this geometry, which is the 3D stuff. Because we currently just have the, we don't know edit to do any of these pocketing operations. So what we'll do is look at the output of OpenNest where it goes. It'll give us the geometry. It also gives us the ID, the order in which everything is. It also gives us the sheet number. So, for geometry number 1 or 0 will be on sheet number 2. And it gives us the transforms as well. And the transforms are essentially transformed object. So if I take all these and apply this list of transformations, it does that. So it's essentially a bunch of like movement vectors. And I don't want to explain transforms now because I'm not very good at them. So then if we just replace the polys with what came out of the packing component here, we have all our 3D geometry in place and the right side up, which is great. Very, very great. And I think we'll call it around here for now. In the next video, I want to show you how to take what OpenNest has given you and start to turn it into some shop drawings. So drawings that we could give to a fabricator to CNC mill. So I'll see you then. Take it easy.